All right, everybody, good morning. I'm not feeling so good today, so I'm sorry, but I'll be out. You'll have a substitute. For your opener, I just want to go over a couple things, show you how to graph exponentials, and then you should be able to do some of the practice on your own. So just a gentle review. To get x by itself here, we would subtract 4 from both sides and divide both sides by 2 to get x equals 16. If you have an exponent of 2, it's a quadratic. It's going to be the same first step. We'll still divide by 2. And remember, when you square root both sides, you get plus or minus 4. That's a little bit different compared to the linear, which only has one solution. All right, number 3, what happens if you have a variable in the exponent? So kind of like the first two, we're still going to subtract 4 from both sides. So 2 to the what is 32? This was a little trickier. So 32, we can rewrite it with a base of 2 because 2 to the 5th, so 2 times 2 times 2, 5 times, is 32. So now that we have the same base, we can just look at the exponents and say x is equal to 5. So I set x equal to 5 and we're done. Number 4, they already have the same base, so 2 to the something equals 2 to the something. That means we can take the exponents and set them equal to each other. And then getting x by itself, I'm going to subtract 2x from both sides. Subtract 1. And I got x equals negative 4. What happens if you have the variable in the exponent, but you don't have the same base? So we have 9 and we have 27. Well, we can rewrite 9 as 3 squared to the x power. So I'm just going to bring that exponent down. And 27 is 3 to the 3rd. And if you remember your properties of exponents, when you have a power to a power, we multiply. So I'm going to distribute the 3 to both of these terms here. So and we essentially changed the base from 9 and 27 to a base of 3. So now that we have a base of 3, we can set the exponents equal to each other. So let me bring this over here. Subtracting the 6x from both sides. And then dividing by negative 4. We get negative 3/4. All right, so we're going to look at graphing exponentials. If you had y equals 3x, that would just be linear. It would pass through the origin. And you don't have to write this down, but basically, if it's y equals 3, times x, it would be increasing by 3 each time. So plus 3, plus 3, plus 3, and plus 3. We're going to be graphing exponentials, so y equals 3 to the x. And this one's a little bit different, so let me do this. So if you do 3 to the 0, that's actually going to be 1. 3 to the first would be 3. 3 squared would be 9. And 3 to the third would be 27. So you're not going up by 3 each time, but rather you're multiplying by 3 each time. I left some space here because if you go 3 to the negative 1, that would be 1/3. 3 to the negative 2 would be 1/9. So it never reaches 0, and that's what's called the horizontal asymptote, is that it gets closer and closer to 0, but never quite gets there. So this is going to be for y equals 3 to the x. So here are the key features for y equals 3 to the x. This is just a visual that if you start with one person times 3 times 3, that's exponential growth. So this is kind of like stage 0. Stage 1 would have 3 people. So if we plot those points, so 0, 1, and 1, 9, I think that's all we're going to have room for. Let me draw the horizontal asymptote. Let's do this. Okay. And we're going to do our best to draw It's not going to be perfect, but it's going to be this exponential curve that passes through 0, 1. Sorry. It should be 1, 3, and 2, 9. It's my bad. There we go. So it should pass through 0, 1, 1, 3, and 2, 9. I was going to say, it seemed like too steep of a graph, so that's my apologies. I don't know why I graphed 1, 9. It should be 1, 3, and 2, 9. All right. So 2 to the negative 3, that would be 1/8. 2 to the negative 2 would be 1/4. So I'm just going to fill these in here. But basically it shows that if you go really far to the negatives on your x, you're going to get closer and closer to 0, but never actually quite cross there. So that's going to be your horizontal asymptote again at y equals 0. So we're going to do 0, 1, 1, 2, 2, 4, and 3, 8. So this is exponential growth. All right, the last one I want to do with you is this one here, and you have to be very careful when you sub in your x values into your, oops. See if it'll let me just highlight the x. Okay. So this would be 2 to the negative 3 minus 1. And we're going to sub in the x coordinate. So this is just kind of building the pattern here. So 2 to the 1 minus 1. So again, if you just wanted to set up like an XY table, you technically only need 2 coordinate points when graphing. The first number I would sub in is 1. 1 take away 1 if I look at the exponent up here. 1 take away 1 is 0. 2 to the 0 is 1. And then I would sub in 2. 2 take away 1 is 1. 2 to the first is 2. So I get the coordinate points for this one here. This is just the graph of 2 to the x, so let's just do a different color. The graph, oops. Let's see how I do here. So basically, this is a shift, just like it's kind of opposite of what it appears to be. So this is actually a shift, horizontal shift to the right one. If it was to the x plus 1, that would be a shift to the left by 1. All right, so give the other examples a shot, and I will see you tomorrow. Have a good day.